Hello and welcome to Day 2 of Roundtables Europe by PV Magazine, where the future of PV is one that is ubiquitous, reliable, high efficiency, underpinned by new business models, and powering the green economy. I'm Jonathan Gifford, the editor-in-chief of PV Magazine Global. But before we get into the substantive sessions for our Roundtables Europe Day 2, I'd like to take a moment to thank our partners for the event. Our lead partner, Trina Solar, and our platinum partners, Axpo, Jinko Solar, Longi, Seraphim Solar, Smart Energy, Solar Edge, Studer Cables, and Wave Labs. Well, a vision for hope is one with solar everywhere. It may seem a long way off, more science fiction than fact, but the emerging applications today are going a long way to demonstrate this vision. PV Magazine editor Blake Matich covers emerging applications for us at PV Magazine, and he's co-hosting this Solar Everywhere session today.
Thank you, Jonathan. And as you can see behind us, we have a vision that you might recognize as solar punk, which is a wonderful aesthetic genre which incorporates renewable energies into a vision of the future. So you can imagine these are transparent panels, and it's more or less completely submersive. Now, this particular vision is provided to us by Hendril Silveira of ASMR Weekly, a very successful YouTube channel, and he created this in collaboration with Connor Louisiel of Solar Punk Storyworks, who wrote a novel called Seraph City. Now, Solar Punk itself shows a built environment in which solar is integrated everywhere, from our buildings, facades, rooftops, to our agriculture, and of course, even floating on water, perhaps even in the air one day. And that's precisely what we're discussing today. Whether it's building integrated photovoltaics, BIPV, floating photovoltaics, FPV, or agrivoltaics, such as those which could have great potential in densely agricultural countries like France, there is enormous potential across the board. But first, let's get into the cities.
Building integrated photovoltaics, or BIPV, has long been mooted as one of the most innovative and promising solar applications, but it's invariably underwhelmed when compared to the stellar growth that's been achieved in other applications. So let's look at a bit of the data now. Let's crunch the numbers on the expected growth of BIPV in Europe.
Now, you can see here on this graph, we have a cumulative history of BIPV in the European market. So obviously we have an initial upswing in 2008 and up until 2011, along with the rest of the market. But then we have a tapering out and a kind of dulling of the increase over the years, along with the wider area of the European market. But looking ahead to 2025 and 2030, and by the way, these figures and this data all comes from the Becquerel Institute in Belgium. We're thanking them for this wonderful research. And here we see our renovation rates, which is a potential driver of new uptake, particularly with recent European policy. So we can see pretty consistent increases in renovation rates, particularly in the south. And when we come here to some market projections over the next 5 to 10 years, divided between roof and facade, with roof obviously dominating those projections because the facade technology will still take a little bit of time to mature. But if we jump ahead finally to these eventual data, and we have a high forecast of, a low forecast of 7.4% going into 2030 and a high forecast of 9.5 gigawatts. Quite a significant change in the market over the next 10 years. So looking forward to talking about that with our expert panel. Now, to discuss BIPV opportunities, we are joined today by two of our expert panelists, Samira Jama Aden from the Helmholtz-Zentrum Berlin, where she works on the BAIP initiative, and which looks at to bridge the gaps between the construction sector and PV industry, and Teodosio del Caño, who is the CTO of one of the leading BIPV module producers, Onyx Solar. Thank you very much for joining us. Samira, beginning with you, what is your take on the BIPV projections we've just seen? Are you similarly optimistic? Do these projections seem accurate to you?
Yes, I'm actually really optimistic at the moment because we receive here at the consulting office a lot of projects and even like renovation projects that people really want to improve their buildings towards renewable energy. So I think the market is growing at the moment. And I see even that architects are more and more using these materials even in their design options in the early phase of planning, what brings them to a success.
That's wonderful to hear. And turning to you, Teodosio, what is your view of this coming renovation wave? Are you seeing opportunities in the brownfield market already, or is Onyx mainly focused on greenfield opportunities?
I think we see a exponential growth in the market for both new buildings and renovation, because from one side, it is needed in renovation buildings to decrease the energy demand per square meter, and it is obvious that we need renewable energies on site, and the best way is to do building integrated photovoltaics, and at the same time, as we all know, the added aesthetical value that we are getting right now with BIPV has improved a lot in the last years, and you see beautiful solutions that can be integrated in renovated buildings. So obviously, renovation is an important part of our niche of market for sure.
Wonderful. And staying with you, Teodosio, after years of stagnation politically, the wheels are now turning. In Europe, and some of the EU-led policies, such as rooftop mandates, particularly where I'm broadcasting from in Berlin, have a potential to impact the market quite significantly. What's your view on these policies?
Policy making is important. From the time that we got the European Directive for Energy in Buildings, there were some optimistic details on that directive. At the same time, right now, we believe that there are nice policies going on all over Europe. As you pointed out, in Germany, we see some in France, we see some in Spain, also Italy too. But at the end of the day, what it is important is that this is a business case for the final client, and especially that the new regulations and the new directives do not become a constraint of the market. Let's put it this way. What we need is that policies are easy to follow, and at the end, if someone wants to integrate BIPV on a building, it has to be easy for them. In terms that obviously they must meet the standards, they must meet the regulations, but there should be no constraints on making things really easy, for instance, in safety viewpoints or regulations or everything getting too complicated. This is how I see it.
Very interesting. And opening the floor to you, Samira, do you see the policy in the same way? Are we trying to keep it simple, or should we be driving with harder policies?
So I think policies are important that architects start to use it, because then when we have policies that are forcing to use renewable energies in buildings, architects will start to use it. At the same time, we have a lot of parameters that are in the regulations, and we have a leak of standards that makes the planning really difficult and is not really competitive to other materials. So we have to start actually to have strong regulations, and we need standards even in BIPV, and the policy needs to open this floor actually.
Very interesting. And speaking of materials, thin film technologies, due to their homogeneous appearance, have been touted as the BIPV product for a long time. But we're now seeing a lot of innovation in the form of crystalline silicon manufacturers. Teodosio, how are you viewing this development in terms of materials?
Thank you. I love the question, because actually in the last 4 or 5 years, we are doing beautiful things in crystalline. I mean, thin film, obviously, it is a technology with an added aesthetical value, but low performance. But right now, in the case of crystalline, we are doing beautiful things. We are introducing colors. We are doing high-end PV materials. Actually, you can combine it perfectly in facades with other ceramic tiles. You can combine it with aluminum, and you can combine it with a stone, and you could not tell the difference with what is PV or not. So really, really high-end PV, full color BIPV solutions are becoming really, really nice, and we are doing an extraordinary effort in such a way that our materials can be accepted by the final clients and meet all their aesthetical needs. In that sense, we have seen an exponential growth of the demand of crystalline technology for BIPV in the last 3 years. Actually, I would say that 5 years ago, we were doing maybe 40% thin film, 60% crystalline, but right now we are close to 80% of crystalline because the solutions are beautiful. So this is what I have to say about this point.
Fantastic. And Samira, from an architectural point of view, do you have an opinion about the shift in technology?
Yes. Actually, what I would like to point out is that in architecture, when we plan with BIPV, it's not always about having the highest efficiency. So we are actually dealing with other design parameters. Where's the building standing? What kind of idea is in the design, in the aesthetic part? Then we have the structural facade planning part, where we have to think about what kind of construction we are using. And then we have even the photovoltaics as the material we want to implement in our building skin. So the trend is actually what is the individual building appearance or the aesthetic value that you want to achieve. But we see even that now at the moment silicon-based modules are even more and more asked because the surface is more and more getting in colorful. You can have different pigments coated on the glass fronts. So it's more and more pushing forward because you can achieve high efficiency at the same time and have this colorful surfaces of these models. So it's actually individual, I would call it. It depends on really the building tasks we are working on.
And that's perhaps why, Teodosio, European manufacturers have actually been able to maintain competitive market share, whereas in other markets, in other sectors of the European market, it's been taken offshore. Why do you think that is, and do you think Europe will be able to maintain its BIPV market share?
I would say the first reason is that we are good. I mean, the BIPV manufacturers in Europe, we are really good companies. I mean, I don't see other BIPV companies as competitors. I see them as partners. And honestly speaking, you see really good companies in Europe doing awesome and beautiful BIPV. So the first thing is that we offer an outstanding quality. Secondly, this market niche is still small, but is growing exponentially. And the problem that we are having is that even we are not able to satisfy the demand. If you keep in mind all the BIPV companies in Europe and our turnover together, and we see your data of the market growth, there is no way that we alone will be able to fulfill that market demand. So sooner or later, some new players are going to come and new stakeholders are going to come. I don't know how it will happen, but for sure we will have new players. And the good thing about it is that we, the existing companies, we have over 10 years of experience. And I think that we can maintain this important market share in BIPV because we are good, we offer quality, and we know what we are doing. And new players, for them, the learn curve in this sector, which is very competitive and very difficult, is long. So this is why we believe that we are in a privileged position. And right now, what we have to do is to grow and keep doing things right.
Fantastic. I'd love to ask a few more questions, but we're running short of time. So perhaps I could just ask you to finish this sentence. The future is bright for BIPV in Europe because, starting with you, Samira?
Because there's no other way out.
Fantastic. Teodosio?
Sammy did it perfect. I don't have another sentence because
Said
she's right.
and done.
She's fully right.
Thank you very much for joining us. Very interesting conversation. Thank you for joining us at
Yes, thank you
Roundtables
so
Europe.
much. Thank you.
Thank you very much for the invitation.
Well, while we are very much focused on future-looking PV applications in this session today, there are many lessons that can be carried over from solar industry's early days. Jan Mastny has been with PV for close to 20 years and has seen a lot of lessons learned, frequently the hard way. He is now the head of sales for DC cabling provider Studer Cables, and he joins us to look at the importance of high-quality components from a balance of systems standpoint, and in particular in challenging environments, like on building surfaces or on water. Jan, welcome to the Solar Everywhere session of Roundtables Europe.
Good morning, Jonathan, and thank you very much for the introduction.
No, my pleasure. It's lovely to see you. Now, take us through some of these lessons learned over your almost 20 years of experience in PV.
Yeah, do we have the connection? Because I just lost the...
We do. We can still see you, and your presentation is now live.
All right. So, first of all, thank you very much again for having the chance to be with you today. And my goal today is to present a set of myths which are happening around the PV and which are still actually, after those almost 20 years, happening all over the projects which I can see. So solar everywhere, and I think the name of this roundtable session says it all. But the question is, which we need to ask ourselves, do we also have the safety and quality everywhere? And the more we get exposed to the PV, the more efforts are needed to show that PV is safe, reliable, and sustainable. And during today's presentation, let me show you some of the myths. And in case you will keep believing those myths, for sure you will lose the enthusiasm for the industry, and of course you will lose a lot of money. So as I have mentioned, the PV is really everywhere. We have plenty of rooftops applications or building integrated terrestrial installations, floating PV, and a huge variety of special applications. You were talking yesterday about BIPV was very interesting, and of course there are more and more applications coming up. But as we do not wear the flip-flops in the snow, we should be aware of the ambience where the projects are really installed. That means do not believe that the massive snow load on the rooftops or exposure to the moisture on the floating system does not represent any risk of faster degradation. And it certainly does. And for that reason, keep in mind that the ambient specifics, and do your best to select the materials which fit to your project. Ignoring this will lead simply into the faster degradation of your installation. It is not a question if, but when. Believe me, 25 years is quite a long time, and ignoring those aspects is a mistake which you will certainly pay for. It is amazing how many people still today ignore the standards. Unfortunately, there are many cheaters who also say to the customers, you don't need to follow the standards. Standards is only a recommendation, not a law. And let's put aside the very specific standards for conditions like floating PV or direct barrier for now. Imagine nowadays in Europe, we have more and more thunderstorms followed by hail. Or imagine environment with heavy soiling. Or finally, imagine installation somewhere in the mountains with a heavy snow load and much stronger UV exposure. All of those examples will be guided by the same normative requirements. And now comes the important part. The standards are typically indicating the very minimum requirements because the standard is a compromising point that is applicable to all the PV installations. This means reaching the requirements of the standard is where the quality and reliability actually begin. Reaching the certification is not a finish line. Therefore, the smart investor will compare the suppliers not only based on the pricing, but also based on the parameters and characteristics which are above the standard. Smart investor will seek for products which give him more than what the guidelines require, because the smart investor can foresee the risks which might arise in the period of 25 years. And believing that the standards and certifications are only a formality is wrong. And being wrong in PV certainly means additional expenses. Underestimating the installation itself is a very, very expensive mistake. And this mistake might not only cost you money, but it will destroy your reputation and it can bring you to the bankruptcy. Things like overloading the conduits or open connectors exposed to the rain. Very famous and very much discussed connector mismatch. Insufficient protection of conduits, or even damaging the modules of all kinds. Those are only few of the common mistakes which I see by visiting the power plants. Those mistakes are a result of a lack of skills of the workers, and this phenomenon happens basically worldwide. Therefore, in my opinion, the investor shall require the EPC to provide that the installation teams are trained properly. It is important for the people on site not only to understand what they shall do, but also why they do things in a certain way. That's the only way how they can make the things improve. And also make sure that the project is done by skilled and trained workers. If you don't ensure that, the O&M costs will get very high. And special applications like floating PV or building integrated PV will cost you even more. Exceptions might exist, but believe it or not, reliability and safety have its price. Typically, the serious suppliers invest into research and development for the products specifically dedicated for a specific use or specific purpose. And they also invest a lot of money into stabilized quality measures and independent certifications. But even in Europe, I have witnessed buyers who are purchasing their materials via all kinds of strange e-shops or no-name companies. To show you an example, I have highlighted the nonsense statements in yellow color, which shall be already a warning for you. Also see that the prices are suspiciously low. Of course, I was asking all three manufacturers and they declared their products are certified. In addition, you see that all of them are using red cables, which can bring you into the trouble because of the absence of UV protection. And by the way, it's not aligned with the standard. Therefore, bear in mind that the investment into PV is not CapEx only, but you also need to consider the OpEx costs, which in case of using lousy products will be high. Price as a main criteria for selection of bill of materials will cause you headaches. And speaking of BOS specifically, replacing the module or a damaged string inverter does not require much effort. But changing cable structure or reassemble new connectors is a very complicated, time-consuming, and expensive event. Believe me, you do not want to experience that. In the last point, somehow, I would like to wrap up all what I said before, and it's the trust. Here, I'm not talking about the trust between the good business partners. I'm talking about trust, which is a result of laziness. People tend to trust the supplier. People trust what he says. People trust what is written in the catalog. People trust him because it's easier than asking questions and looking for the truth. I have prepared one example for you. A customer has asked for a termite-resistant cable, and he got this data sheet from one of his suppliers. First of all, the construction as described here is a nonsense. Why? The customer is not aware that the armoring in the string cable must be grounded. How should this be done in this case? The customer is also not aware that the PV connector for an armored cable does not exist. So what to do? And the customer is also not aware that the metallic armoring in a DC cable will function like a huge capacitor. Besides, there are other statements which could be simply considered as a lie, but this would be a topic for another presentation. And therefore, do not trust the supplier as a result of laziness. As a smart investor, keep in mind that even the least expensive item can cause a fatal damage. Pay attention to the suppliers and select those with a long history, with a good reputation and performance on the market, and with a solid reference list on the products, but also the customer service. If you only trust, be ready to pay for it. Trust as a result of laziness shall not be part of your business. This brings me to the end, and I have noted quickly 5 objectives which can be very expensive for you. And please take the chance, learn from the mistakes of others so you can save yourself the headaches and, of course, money. Stay away from the myths which were presented here. And also thank you, PV Magazine and Jonathan, for the opportunity to speak here today. Hopefully we get a chance in some next future event to discuss the other expensive mistakes, because there are plenty of them. Okay. Thank you very much for watching. Thank you.
A salutary warning from Jan Mastny, but also some good tips for successful project completion. And Jan, thank you very much for your support of our roundtables over many years as an attendee, as a speaker, and now as a partner. Jan Mastny, the head of sales for Studer Cables, joining us on Roundtables 2022 in this Solar Everywhere session. Now, Now, to integrate PV into buildings, a whole new set of safety considerations must be taken into account. And on water, the challenges to durability significantly increase. But PV suppliers are building expertise in meeting these new high standards, and Andrea Viaro from subcomponent supplier Stäubli has been involved in a number of projects that point to ways in which these additional challenges can be overcome. Andrea, thanks for joining us today.
Hello, Jonathan, and thank you for the opportunity to participate also to this edition of the Roundtables.
It's a great pleasure. Well, let's get stuck straight into it. We've been talking BIPV, and we have some wonderful BIPV images provided by Stäubli that you have been involved in, actually a whole range of very challenging projects. So let's talk BIPV first. What are some of the keys to success, particularly with safety in mind?
Yeah, well, we have already some track records on BIPV, and where, of course, is required not only long-lasting components, but also safe and reliable solutions, which can, of course, prevent failures and having long-lasting application. And also talking about connectors, it's also important considering that despite building components are not supposed to be replaced during the lifetime of the building, of course, there might still be the need for some maintenance, which requires some disconnection or rearranging of the cable. So that's also the reason why quick connectors are still needed for these applications. And the picture that you've just shown, there was one of the success stories that we could contribute in the past. The Grosspeter Tower in Basel is one of our one of the buildings that was constructed in PV, probably the first project in Switzerland with a complete BIPV facade, and was the first project also developed by Planeco, the engineering and construction company, that also developed the installation on the Matzi, also in Switzerland on the Dam. I think in the terms of challenges, or probably regarding the Grosspeter Tower, for instance, just an example, probably the main challenges talking about BIPV is the fact that we need to match basically the timing on construction planning and supply of PV components. And that's probably one of the bottlenecks when timing is critical, or when supplies is delayed, so that components need to be supplied at the right time, at the right place. And in these cases, for instance, of the Grosspeter, we had few months delay on the PV module supply. And in talking about connectors, we had to use protective caps, for instance, for the connectors, to make sure that for the few months that the cabling was exposed to environment, there was no degradation of the metal contacts, so to prevent degradation and to assure a very long-lasting and reliable connection afterwards.
Well, exposure to the environment is also a very big challenge in floating applications, FPV applications. What advice do you have for developers in terms of this balance of system equation?
Well, when talking about floating or harsh environment applications in general, it's clear that quality becomes paramount, and the importance of quality increases significantly in contexts where high humidity or high altitude or low temperature are really critical parameters. We already see possibility to apply our connectors. We already have track records also in that, even though, as mentioned by Jan Mastny probably before, there is still a lack of regulations on this, which is still minimum requirements. But of course, there is a need for more regulations and guidance on the quality of the components or the requirements of the components used for this application. Despite that, we already tested our components, our connectors beyond standard. So we already exceeded the IP68 minimum requirements. And we made sure that also connectors can reliably perform even for 7 days into water, 1 meter depth, without any degradation or deterioration of the properties and reliability of the connectors.
Well, in our next segment, we're talking offshore floating. Saltwater, I imagine, is a whole order of magnitude more challenging in terms of durability. How possible do you think offshore floating is in the future?
Well, that's the new frontier, right? Floating is already taken off, but clearly there is pilot projects already near shore and offshore being deployed or explored. The main challenge, probably talking about connectors or cabling, is not really the salt content in the water, because plastic materials are somehow resistant to that. That's probably more a challenge for the metal components. But when talking about floating in general, especially offshore, the problem is the waves and the fact that the plant is not fixed on ground and it's moving, which requires clearly not only anchoring, but also fixing the cabling and the connectors to the structure to prevent damages or potential hazardous situation for the plant. And talking about offshore, especially on latitude where temperature can be very low, icing is also a problem because of the splashing of the waters, of the waves. Could be accumulating ice on the cabling and the connectors, therefore inducing extra stress due to the mechanical load that is not initially considered. So there is challenges that are not usual, clearly. And when we talk about clearly new frontier applications like offshore floating PV, the challenge is just around the corner.
Well, Andrea Viaro from Stäubli, it's wonderful to be able to discuss some of these challenges with an industry veteran like yourself. Next, we're going to hear from some upstart companies, some new companies that are really looking at these new frontiers. But thank you very much for joining us at Roundtables Europe.
Thank you, Jonathan. And I think that as a conclusion, I could say that with the support of regulation,
Okay, let's go beyond the shore. Unfortunately, we lost the last point from Andrea. I think he was saying that regulations, with the support of regulations, these new frontiers may become a reality. Now, let's go beyond the shore and look at really a cutting-edge application of photovoltaics, floating PV.
Floating infrastructure may seem like something out of Star Wars, but of course we've already seen it in oil and gas, and solar is also taking the lead. Floating PV is already a strongly growing niche, and both onshore and increasingly offshore. After all, in many regions of the world, land shortage is as serious a concern as renewable energy needs, and with floating PV, to coin a phrase, we can hit two seagulls with one stone. Now, we're going to hear from two startup companies today who are taking floating solar offshore. We're joined by Alexander Telje, Chief Commercial Officer of Ocean Sun, and Philipp Sinn, CEO of Sinn Power. Thank you very much for joining us today. We're looking forward to your presentations, starting with Alexander from Ocean Sun. The floor is yours.
Well, thank you very much, Jonathan. It's a pleasure to be part of this roundtable, and it's going to be a pleasure to introduce Ocean Sun and the application we've done for floating solar. I hope you can you see my screen now?
We're looking at just your handsome face at the moment, but I'm sure your presentation will come up momentarily.
It should be a nice floating ring there somehow.
Oh, I know what it looks like. It's a fabulous application, so that'll come up any moment. If not, we might just have to talk about it and use our imaginations.
Well, if you can't see it, I can try to explain it. I think I have tried to do my best to get the screen up here. So
there we are.
Yeah, there we go. Perfect.
Thank you very much.
Well, just briefly, again, thank you for being able to talk a little bit about floating solar and Ocean Sun. Ocean Sun is a fairly new company. We've been around for 5 years. We are relatively small. We're also geographically, we have a good presence in the footprint with an office in Shanghai and also in Singapore and a representative office in the Americas. We got listed in 2020, so we have enough fund to do the proper organizational and product development as we move further as well. What you see here on the screen is one of the installations, one of the first installations that we did on the west coast of Norway, obviously near shore, slightly offshore in rough conditions. And I think it illustrates very well the difference between, let's say, the traditional floating solar, platoon-based, and our solution. Most of the solar has been trying to take basically ground-mounted system and put them on water. We kind of done the other way around and taken advantage of more than 50 years of the aquaculture industry in Norway when it comes to all the mooring and anchoring design. The whole structural element of this solutions is based on some very, very well designed and proven effects. And I think also you can see the circularity of this, which obviously then distributes the forces very differently to the system. Our horizontally placed panels obviously reduces significantly the wind drag through the system. And we employ just one single membrane. And that allows us to basically have both these panels essentially water cooled. And certainly we can fit 72 diameter of this membrane into a 40-foot container, even two of them at times, bringing us basically able to have 1.3 megawatts of floater material in one 40-foot container. Just looking a bit about applications that we do. I can see the picture, then there we go. This is a ring that we now built recently in Albania together with Statkraft, which is the largest renewable company in Europe. And we certainly see hydropower dams as maybe the lowest hanging fruit in the system. This is going to be part of a 2 megawatt system very shortly, hopefully being finished this year. We also have an applications in the hydropower dam in the Philippines together with Scatec. And when we talk about robustness, that's built after the building code being able to handle up to 275 kilometers of wind. It's lasted for more than 2 typhoon seasons, so we are pretty confident that we have the structural integrity in the solution to withstand more rough met ocean data conditions. Near shore, we also now building a system in Singapore, which obviously I think is going to set the benchmark for a lot of the applications in Southeast Asia. We're doing an application and a solution in the LOC in China. And we certainly also see now that regulations are coming into place, that Greece, Spain, Portugal also are being able to serve and offer a market and projects in those nearshore applications.
Thank you very much, Alexander. Sorry to interrupt you there, but we are running a bit behind time. Thank you for catching up a bit on the presentation after the initial delay. It's now time to throw over to Philipp Sinn, CEO of Sinn Power. Take it away, Philipp.
Yes, hello. Thank you very much for inviting me here for my presentation. I try to share it. Can you see my screen here?
Not just yet, Philipp. There we are.
Not yet.
Wonderful.
Is it there? Yeah, okay. Yeah, Sinn Power is founded in 2014, so we are a little bit older than Ocean Sun, and we're coming actually from producing energy out of ocean waves. We have started to do that successfully in our stand in Heraklion. I'm now sitting in Munich, Germany, where we have our main offices. And in Heraklion, there we are testing this ocean power for quite a bit. From there, we came into the idea to develop also multiple floating solutions. So our main power plant is the S-Ocean. This is a massive, large, offshore-proof power plant, which can take solar, wind power, wave power, can withstand significant waves of 12 meters, which means a maximum wave of 20 meters, and enormous storms. Obviously, the parts which are placed on top, like photovoltaic cells, they are only rated to 30 meters per second, so you have to be careful here. Out of this, we also developed two other platforms which are really alike to each other, but a little bit different. This is the S-Lagoon and the S-Lake. The S-Lake is more or less the standard FPV you know from everywhere in the world now. This is a really strong growing market, but we believe this will shift to the oceans. And there's an intermediate between offshore and nearshore lagoons. We have heard that before in the Red Sea, in all those of Malaysia, etc. You will go rather for the S-Lagoon than the S-Ocean because it will be more cost efficient. You will see that in a second. Also, we provide our own power electronics. I don't want to talk about this today, but we have as well EPC companies which do the whole implementation and operations of this, because it's a new technology, so we have to have experts. I think we have heard about this quality issue before, that is a critical point to enter the market here. Yeah, what does it mean? The S-Ocean, that's where we come from, wave power initially, and we have added solar on top of that. You can see the dimensions. We have a range of 6 to 12 meters in the width and length, so it depends on how heavy duty you want to carry, if it's only solar or on inverter technologies, etc. You can add wind turbines and wave power devices, and you see it's 6 meters high, so it's 6 meters above the ocean surface, which is important if you get to larger waves. The S-Lagoon is something much smaller. It's the same principle. You have a construction with which stables each other like a bridge or something. It has a height of 2 to 3 meters. So you can take waves which are up to significant wave heights of up to 7 meters. Significant wave height, that means up to 10 meters maximum wave height. And the S-Lake is up to only for lakes and lagoons we have seen earlier. All of these components are fully saltwater proof and are designed for the ocean as well as sweet water. Here are some images where we are going to. So the S-Ocean is more for really the offshore industry to produce hydrogen at the offshore platforms. The lagoon stuff, we have heard about these markets. There are many markets around. We have a lot of demand on our platforms in Italy, Greece, but also the Far East and Asia. And everybody knows about these projects where we are talking about dams or artificial lakes inside countries where you have little waves and little wind. I think that's about it.
Thank you very much, Philipp. Yes, that's a wonderful presentation and two very disparate novel applications there, two different ways of doing it, but both equally interesting. So thank you very much for joining us. And we're about to move on to our next segment on agrivoltaics.
Thank you.
With increasing land pressures and clean energy needs, symbiotic solutions have great potential, particularly in Europe. Now, solar integrated with agriculture, also known as Agri-PV, is one such application. And in Europe, the promise is perhaps greatest in France, where much of the country is characterized as agricultural and therefore PV developers are locked out. To discuss it today, I am joined by Nathanaël Kasriel, Chief of Staff to the CEO, France Agrivoltaïsme. Nathanaël, thank you for joining us.
Thanks for the invite.
Now, French President Emmanuel Macron singled out Agri-PV as an application that has a big role to play in the country's clean energy future. On the back of this potential, 5 companies joined together to form France Agrivoltaïsme, and one of the first tasks was for the members to define exactly what agrivoltaic or Agri-PV is. What did you come up with?
So on this question, I would have 2 answers. The first one is on the creation of the association. We decided to define agrivoltaics as a climate regulation tool for agriculture that also produces solar energy. So basically, the agrivoltaic structure has to provide the service, the climate regulation service to the agricultural production. It's not just an additional revenue for the farmer. The second part of the answer is the answer that gave the Aden, the French Energy Agency, like a month ago. They released a guide on Agri-PV, on agrivoltaics, and they defined Agri-PV as a photovoltaic structure that has to provide a direct service to agricultural production. So this service can be on several segments, such as climate protection, but it has to have an agricultural role.
That's very interesting. And so if in an agriculturally dominant country like France, if the association's definition becomes operative, then you have a system in which solar has to work for the agriculture. Are you seeing farmers being particularly interested or positive about the solution?
Yes, exactly. And in fact, in France, it's also a matter of life or death for agrivoltaics, because if you just use solar energy as an artificialization of agricultural land, you will have a very low acceptance among farmers. While if you provide Agri-PV as a service for agriculture, so as an agricultural tool, then there is not only a higher acceptance by farmers, but they are willing, in fact, to develop those projects. And in France, it's particularly the case, and I guess in Europe, in Southern Europe too, with the recent climatic events. In all the spring 2022, you had frost, you had hail, you had droughts, and so agrivoltaics is really on top of the news for farmers.
And what challenges do you see lying ahead, particularly in this field?
In this field, for me, there are really 2 big challenges. The first one is acceptability, as we previously said, but it's a challenge that can be tackled with a good definition and a good regulation framework. And the second one is the market. To ensure a good development of agrivoltaics, you need a willingness from the farmers, but you also need a willingness from the French state, and that means feed-in tariffs, particularly. And so the big challenge is to have a regulatory framework that allows a fast development of Agri-PV projects, but also that would give farmers trust to make the development of those projects possible.
And what kind of projects are we seeing already? Of course, if we go to France, we see a lot of vineyards, we see a lot of different kinds of agriculture. What kind of projects are already in the field?
Well, in France, you have all kinds of projects. You have projects on crops, so on vineyards, on orchards, but also greenhouses or market gardening. You have projects on livestock, especially on poultry or sheep. And you have projects, so this is on the agricultural segment, but you also have projects from all kinds of size, from a few kilowatts to several megawatts.
It's a wonderful, very promising solution, particularly for France. So thank you, Nathanaël, for joining us for this segment. And we're going to have to shift on very quickly, but you were a very nice addition to Roundtables Europe. Thank you.
Thank you.
Well, thanks to you, BK. A wonderful session. I think some really promising application, some good tips as to how these promising frontier applications of PV can be achieved. And we kicked off this session with the solar punk visions for the future. And I think we can now see that these novel applications for PV are really, we're already on the way to the journey, to achieve these really novel frontier applications. It's really encouraging.
Certainly is, and perhaps after this session, we can safely say the future has arrived. What is next in the very next few minutes? Well, you can join the speed networking session, or you can take a break and explore the platform. Before we jump into our next session, deploying high-efficiency PV, cell and module manufacturing trends and concepts. See you there.